The last method is Latin square. The corresponding ANOVA table is here. Sum of variance, sum of squares, degrees of freedom, mean square, rows, columns, treatments, residual or error. So the extra thing is here we are having treatments. Okay, so SSR, SSC. For treatments, sum of square is SST and error as usual SSE. Now degrees of freedom is here n-1, n-1, n-1. Here n-1 into n-2, and mean square between rows is SSR divided by n-1. This is MSC. Between columns, SSC divided by n-1. Between treatments, SST divided by n-1. Mean square of residual on the SSE divided by n-1 into n-2. Total of sum of square is TSS equal to n square. Degrees of freedom is n squared minus 1. And SSE can be calculated from this formula. TSS minus S minus of sum of these three values. Now here analyze the following results of a Latin square experiment. So here in the problem they are given the data like this. Okay, A, D, B, C first column and the second column they are given these two columns. Now the solution is consider 12 as origin for simplifying the calculations. So doing a very simple method, we just take an element 12 and subtract that element from every element in the given data. So first A, D, B, C, don't change the order here. So first you, as usual, what is given you take as itself A, D, B, C. Okay, then just subtract the value 12 from each data here. So 12 minus 12, 12, 18 minus 12 is 6, 12 minus 12 is 0, 16 minus 12 is 4. Likewise, all the remaining three columns also you have to find out the values, and also you find out the total, column total, row total, and total of these values. So you are having 44 here. Next one is you have to find the square values of the previous table values. Okay, so here you are having 0, 6, 0, 4. Their corresponding square is 0, 36, 0, 16. Similarly, each column you find out the square of the values, and again you find the total, row wise total, column wise total, and the sum of the total values. Okay, so this value is called as sigma x square. Next, for treatment, when you are considering the treatment table, you have to arrange it in the order A, B, C, D, right? So A, B, C, D. So in this table, initial table, A is 0, then B 0, C is 4, 6. So the value is 0, 0, 4, 6. Okay, so you write 0, 0, 4, 6. Similarly, each column you have to arrange it in the order A, B, C, D, and then you find the total values here. Just only for rows you have to find out the totals, and the sum of the total value is 44 here. Next you have to find out total sum of square. Total sum of squares is summation x squared minus t squared by n. T squared by n is nothing but correction factor. Okay, then summation x squared is this one, 278. 278 minus correction factor is t squared is this value, 44 the whole square divided by n is number of data is 16. So you get the value is 157 here. The next one is sum of squares between columns. Sum of squares between columns is 1 by 4 of 10 squared, 12 squared, 13 squared, 19 squared. Okay, so that is the very first table, the column total. Okay, 10, 12, 13 and 19. Okay, that values you have to consider here minus correction factor. Each column you are having 4, the value is 4, so you have 1 by 4 common value, common for these squares. So after substituting the value you get that value, after simplification you get the value is 2.5. The next one is sum of squares between rows. Again 1 by 4, the initial table the row total. Okay, 10, 9, 11, 14. Their individual square and sum divided by 4 minus correction factor 121. After simplification, you get 3.5. Then sum of squares between treatments. For this one, you have to consider the treatment table. That is, in the order wise, you have to arrange it now, A, B, C, D. And that total you have to consider here. Sum of squares between treatments. 6 squared minus 4 the whole square plus 13 squared plus 29 squared divided by 4 minus correction factor 121. So after simplifying we get 144.5. Therefore the error sum of squares between error வந்து TSS minus the formula SSR plus SSE plus SST. Substitute all the values, simplify, you get 6.5. Then you put all the values in the ANOVA table. Okay, ANOVA table. Then finally you find out the mean square value 2.5 divided by 3, and for column 3.5 divided by 3, between treatments 144.5 divided by 3, and for error 6.5 divided by 6. Using this you find out the ratio. Okay, so this is SSE. Okay, so 0.83 divided by this value, at the 1.17 divided by this one, 48.17 divided by 1.08, the values you are having. Now you have to compare with the calculated value. So F tabulated is 27.91 for 6,3 degrees of freedom at 1% level is. Okay, so the F value for the rows is less than the F value between the calculated. Okay, so and similarly FC is also less than the F tabulated value. Therefore there are no significant difference between rows and columns.